Hi class, so today the lesson is on exponent laws. The learning goals are to learn some common exponent laws and to learn how to apply exponent laws to simplify powers. So let's get into it. We're going to start with a little review first. So first of all, let's talk about what is A times A, or I guess better stated, what's another way to write A times A, or how do you write it as a power? Yeah, that's probably the better question. How do you write it as a power? Okay, so the answer to that would be A squared. So that's what we learned yesterday, the power notation. A is called the base, 2 is called the exponent, and the whole thing, A squared, is called the power. All right, so let's see if you've grasped that. We're going to be a little repetitive here. So what is B times B? Take a second to think about that. Pause the video if you want, and hopefully you come up with B squared. B to the exponent of 2, or the second power of B. These are all ways to say that. Okay, so those are the first two. So then now the next question, what is A times B? What is A times B? So I'll tell you what it's not. It's not A squared. It's not B squared. It's not AB squared. The problem with A times B is that A and B are possibly different values. So we can't really express it as something squared. It's not really something multiplied by itself. So how do we write this? Well, there's actually not really any way to rewrite this or simplify it. Sometimes people leave out the multiplication sign and just write the letters together, AB. When you leave out any operators, it's assumed it's multiplication. This can also be written as BA, because A times B is the same thing as B times A. That's called the commutative property of multiplication. But the point is, A times B, you cannot really write that, you cannot really simplify that into a single power. So we just write AB. Okay, so there's a little bit of review. Now we'll get into today's stuff, which is exponent laws. So we'll go through it with examples. So what if I told you to simplify something like this: A cubed times A to A squared. Okay, A cubed times A squared. How would you do that? So we're gonna break it down into its basic parts. First thing, A cubed. I need you to recognize that as repeated multiplication. 3 copies of A multiplied together. A times A times A. And we will do the same thing with A squared. That's 2 copies of A, so A times A. And we'll also copy down the operator in the middle, this multiplication symbol in the middle. We will copy that down as well, transfer it to the next step. So A cubed times A squared equals A times A times A times A times A. And if you count it all up, count how many A's there are being multiplied together. You should count 5 of them. So the answer is A to the 5. So do you notice something about the answer versus the question? Do you notice any relationships between the exponents? You may have noticed that 3 plus 2 equals to 5. And that's kind of an introduction to the first exponent law, or maybe, well, the first one we're going to talk about. I don't have a very good name for this exponent law, so for lack of a more for lack of a shorter version of this, I'll just write out a long version of this. We will call this the product of powers with the same base. Product of powers with the same base. So in the example, we have two powers multiplied together, a cubed times a squared, and they have the same base, which is a. So whenever you have that situation, the exponent law is that you can actually just add the two exponents together to get the exponent of the answer. So written more succinctly, it looks like this. I will say a to the exponent of m. M just stands for a random number, any exponent at all, times a to the exponent of n. N represents another number. It might be the same as m, it might be different, but we have two different exponents here. And they are all applied to the same base of a. So when this happens, you can actually simplify this into a single power by adding the exponents. So we will express that as a to the exponent of m plus n. Okay, so to summarize, if you have two powers with the same base and they are being multiplied together, if you're asked to simplify it, the answer is the same base, and the new exponent is just going to be the two exponents added together. So we'll do some examples of that, or I'll show some examples of that. Same as the examples above, basically. Let's say you have 2 to the power of 5, or sorry, 2 to the exponent of 5 times 2 to the exponent of 3. So remember, this is another way to express multiplication. You don't have to use that cross symbol all the time. Sometimes it will just be terms in brackets. So I will have I'll ask myself a question here. Do the powers here have the same base? Do the powers have the same base? So when I look at them, they both have the same base of 2. So the answer is yes. So if the answer is yes, we're going to follow the exponent law above, and the answer will just add the exponents. So 2 to the exponent of 5 plus 3, which is 2 to the exponent of 8. So that will be the answer. That will be the simplified version of that, expressed as a single power. Now, you can check that on the calculator if you wish. So I'll do a little check over here. 2 to the 5 times 2 to the 3. So 2 to the 5 is 5 copies of 2 multiplied together. 2 times 2 times 2 times 2 times 2. That actually equals to 32. And then 2 cubed is 2 times 2 times 2. That equals to 8. And when I multiply those together, I get 256. 32 times 8 is 256. Now, we can check whether or not that equals to 2 to the exponent of 8. I can go on my calculator and just type in 2 to the exponent of 8. Or I can type in 2 times 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 2. And when I do that, I also get 256. So that was correct. The answer is correct. So there's one example using numbers. We can do some more using letters. We can go with, let's go with a different letter here. Let's say W. W to the exponent of 5 times, so this dot is often used for multiplication as well. Let's say W to the exponent of 7. So if I have to simplify that, I ask the question, do they have the same base? Yes, they both have the base of w. So in this case, I can add the exponents together. 5 plus 7 is 12, and the answer would be w to the exponent of 12. Let's do another one. How about I use x's? We'll say x times x to the 7. All right. I'm doing this example because for the first x, you don't really see an exponent there, but you need to recognize that that is actually an exponent of 1. Okay, when you have just a letter and you don't see any exponent, that's just one copy of itself, so the exponent is 1. Now, do they have the same base? Yes, the base is x, so I can simplify this by adding the exponents. 1 plus 7, which makes 8. So the answer is x to the exponent of 8. Now, this can be extended for more than two factors. So for example, we'll use p this time. If we have p cubed times p to the 6 times p, we have 3 powers being multiplied together. Do all 3 powers have the same base? Yes, they do. They are all p. So the exponent law still applies. You just have to add 3 exponents now instead of adding 2 exponents. So this will be p to the exponent of whatever 3 plus 6 plus 1 is. So remember, the last p there, the exponent is 1. Add it all together. That makes p to the exponent 10. Okay, so that is the exponent law when you have a product of powers with the same base. Now let's do something a little bit trickier. So another example here. I am going to have 2 letters going on at the same time. So for example, a cubed b to the 4 times a squared. We'll just leave it at that to start. Okay, so this is a little bit trickier. One thing, it looks like we have 2 things multiplied together, but you know what? We can actually visualize this as 3 powers multiplied together, because that first bracket is really 2 powers multiplied together. It's a cubed times b to the 4. Okay, and then we have this a squared afterwards. So we can really visualize this as 3 powers multiplied together. Now, do these powers have the same base? And this time the answer is no. Okay, they don't have the same base. 2 of them do. 2 of them have a base of a, but the one in the middle has a base of b, which is different. So we cannot just add those exponents together, 3 plus 4 plus 2. That will not get us the correct answer. Okay, so we can't fully express this as a single power, but we can partially simplify this at least. Let me just write that down first. We cannot express all this as a single power, but we can still partially simplify this. So what I'm getting at is that we can combine the 2 powers that both have a base of a. So the first and the third power. The middle one, we can't do anything about that though. So what I'm going to do is rearrange this a little bit. So I'm going to rewrite this so the a powers come first, and I'll put the b power last. So sometimes when you get good at this, you might even skip this step, but I'm just showing it for now since we're just starting. And I also I have a preference. I like to kind of go in alphabetical order. Okay, you don't necessarily have to, but it is my preference. So I put all my A's first there and then my B's after. Are we allowed to just move around the order of these things being multiplied together? And the answer is yes, because multiplication is commutative. 1 times 2 times 3 is the exact same as 3 times 2 times 1. It's the exact same as 2 times 1 times 3. Like, it doesn't matter what order you multiply the factors in. So you're allowed to just do that for multiplication questions. So I just put the A's, the two powers with the base of A next to each other. And these two, since they have the same base of A, can simplify to a to the exponent of 5. 3 plus 2 is 5. And then we have this b to the exponent of 4, which I haven't done anything with. And that is as far as we can go. We often write it without the brackets, so just a5, b4, like that. That is as far as we can go. A and b are different bases. So that would be the answer to that question. We can get a little, we can just add more and more letters to make it more and more complicated. Kind of unnecessary in my opinion, but sometimes you'll have to do it in just a homework question or maybe your standardized test or something like that. So we should be prepared for it. Let's say we have, I'll go with p q squared r cubed, and we'll multiply it with p squared q, and we'll multiply that by q squared r to the fourth. Okay. So this one seems like there's a lot going on there. So I would suggest, since everything is multiplication, like every single thing here is multiplication, and it does not matter what we multiply things in, I would suggest just look at all the p's first. Then all the q's. Then all the r's. Let's just take this one letter at a time. And I'll use some coloring to help. So looking at the p's, I see a p in the first bracket. I see a p squared in the second bracket. And I don't see any in the third bracket. So I can just think about what happens when I combine those p's. So I have p times p squared. So for the base of p, the exponent of the answer is going to be 1 plus 2, which is 3. Okay, don't forget that. You can put a 1 on that first p there as the exponent. All right, so I've done the p's. Now we'll look at q's. I see a q squared times a q times another q squared. So all of those q's, multiply them all together. The base is q, and the new exponent is 2 plus 1 plus 2. Just adding those exponents up. 2 plus 1 plus 2, that makes 5. And finally, I look at the r's. I see an r cubed, no r's in the middle bracket, and then I see an r to the 4. So the r power will have a new exponent of 3 plus 4, which is 7. All right, so that is the first exponent law. multiplying powers with the same base. We're going to do something very similar with dividing. We'll start with an example again. So let's say you have, let's say you have 3 to the exponent of 5 divided by 3 to the exponent of 3. Okay, so we can punch that into the calculator if we wish to, and get a number out. That's fine, but I want you to understand powers and exponent laws today. So we're going to take the long way around here. 3 to the exponent of 5 represents repeated multiplication, 5 copies of 3. So that's the numerator. And then I'll draw the line for the fraction. And then the denominator, 3 to the exponent of 3, is repeated multiplication, 3 copies of 3. So when I look at this, I see some, I guess I'll call it canceling out. I see that a 3 can divide by a 3 on the bottom, and then the second 3 can divide by the second 3 on the bottom, and then the third 3 can divide with the third 3 on the bottom. Some people will call that canceling out. So if you look at what's left over, I have 3 times 3 left over, which can be written as 3 squared, which equals to 9. 3 squared is 9. So that's the answer. You can check. Okay, we can do a check. So 3 to the 5 over 3 to the 3. 3 to the 5 is 3 times 3 times 3 times 3 times 3. That actually equals to 243. In the denominator is 3 cubed. 3 times 3 times 3. That equals to 27. And if you divide 243 by 27, you get exactly 9, which is our answer. 3 squared is 9. Okay, so that is correct. So do you notice any kind of relationship between the exponents? We had an exponent of 5, we had an exponent of 3, and then our answer had an exponent of 2. Is there any relationship between those numbers? You might come up with 5 minus 3 equals to 2. Okay, and that's in essence the next exponent law. So I'm going to call this dividing powers with the same base. They have to have the same base. In this case, the base is 3. So the generalized version, I'll use the letters. If you have a power of a divided by another power of a, so they have the same base of a, the shortcut to getting the answer, or writing this as a single power, is to write the base of a, and then the new exponent is simply going to be the exponent of the numerator subtract the exponent of the denominator. So we're just subtracting the exponents for this exponent law. Do some quick examples. We can have a to the 7 over a to the 4. So you still have to ask the question, do they have the same base? And they both have the base of a, so yes, they have the same base. So if that's the case, then we're allowed to apply this exponent law. This will simplify to a to the exponent of 7 minus 4. And 7 minus 4 is 3. So the answer is a to the exponent of 3. Another example, we'll use b's this time. Let's say b to the 6 over b. So why am I doing this example? I'm doing this example to see if you remember that when you just see a letter with no exponent, you need to know that the exponent is actually 1. So this will simplify to b to the exponent of whatever 6 minus 1 is. 6 minus 1 is 5. I should not have chosen 6 to go with b because they kind of look the same when I draw them. And now I'm going to combine the two exponent laws together in this example. So let's say we have c to the 5 times c to the 7 over c times c to the, let's go with, I guess we'll go with 8. Okay, so this question seems big. So we're combining both exponent laws here. I'm going to show my steps. So in my first step, I'm going to simplify the numerator and denominator separately. Kind of 2 steps in one, actually. Okay, so the numerator, c to the 5 times c to the 7. They have the same base of c, so I can add the exponents, 5 plus 7. And then the denominator, c times c to the 8, they have the same base. Did I say base on the numerator? I should have said base. They have the same base of c, so I can add the exponents, 1 plus 8. So that gives me c to the exponent of 12 on the top, c to the exponent of 9 on the bottom. So that was applying the first exponent law, product of powers with the same base. So now I'm left with dividing powers of the same base. So c to the 12 divided by c to the 9, I will have c to the 12 minus 9, whatever. I'm going to subtract the exponents. And the answer is c to the 3, or c cubed. Okay, and now the most complex one for up until now, multiple letters. Let's try that. So I'll say x squared y times y cubed over xy to the 4. Let's try that. So it's all product and divisions of powers here. We have different bases going on. We have x's and we have y's. So it looks complicated, but really simply, just do the x's. Then do the y's. Okay, so it's really 2 questions in one if you think about it. It's really 2 questions in one. For the first sub-question, I'm going to just ignore all of the y's altogether, pretend I don't even see them, and only look at the x's. I'll highlight them. Okay, so pretend I don't see any y's at all, and here are my x's, and just work with the x's. So I have x squared over x. That's dividing powers with the same base of x, so I can subtract those exponents. So it will be x to the exponent of 2 minus 1. 2 minus 1 is 1. and I don't need to write down 1. I can just write down x. Okay, now let's look at the y's. So now I'm going to pretend I don't see any x's, and I just look at the y's. Pretend I don't see any x's, just look at the y's. So in this case, if I look in the numerator, I have y to the exponent of 1 times y to the exponent of 3. So the new exponent is going to be 1 plus 3. But then it's all divided by y to the exponent of 4. So combining it with the next exponent law, I'm going to say minus 4. So that's going to be my exponents for y. And that will give me 1 plus 3 minus 4 is actually y to the exponent of 0, which is kind of interesting. What does that mean, y to the exponent of 0? Well, that's actually a lesson for another day. So for now, I'm just going to leave it as it is. All right, so that is kind of a strange one. Let's practice that one more time, just for practice. Okay, we will say p to the 6 q to the 12 over p cubed q squared p q to the 5. Okay, we'll go with that. So remember my advice. When you have a question like this, 2 different bases, when everything's multiplying and dividing, just do one letter at a time. Just do one letter at a time and pretend you don't even see the other letter. You have to have good, I guess, mental blocking skills to just ignore the other letter and then go back and do it after. So you have to have patience as well. So the first letter I'll do is P's. Okay, so looking at the P's, just ignoring the Q's completely, I have p to the 6 over p to the 3 times p. So we do have to follow order of operations here, BEDMAS, and I don't know if you remember, one time, a long time ago, I gave a suggestion. Whenever you see a big fraction like this, you should always kind of visualize big brackets surrounding the whole numerator and big brackets surrounding the whole denominator. Okay, that is just kind of my advice for, I guess, novice mathematicians when you're just kind of starting out early in your math career, to just visualize that. So then we're thinking BEDMAS, and we have to do brackets first. In the numerator, there's nothing we can do. P to the 6, that's it. There's nothing we can do. But in the denominator, we have p cubed times p, and that actually makes p to the exponent of 4 if you follow the exponent laws. All right, so I'm going to show steps here. In the numerator, I'll have p to the 6. In the denominator, I'll have p to the 4. And those are the p's. And now I'm going to do the q's. So now I'm going to ignore the p's. And now I'm going to look at the q's. And the same sort of thing happens. So in the numerator, it's just q to the 12. That's the only thing there. In the denominator, I have q squared times q to the 5. I can add those exponents to get q to the 7. Okay, so that's my first step. And now I'm going to keep simplifying. So again, I'm going to look at the p's first and ignore the q's. So I have p to the 6 over p to the 4. That will simplify to by subtracting 6 minus 4. That'll give me p squared. Try the same thing with the q's. Q to the 12 over q to the 7. That will simplify to q to the 12 minus 7. 12 minus 7 is 5. All right, so that would be the simplified version of this long, big question. Okay, so that was perhaps a lot to handle at once. So remember, you may have to watch and rewatch some of these examples. You can play this back at 2 times speed, if you want to save some time, stuff like that. But we got to try to understand this. I will try to find other videos on YouTube of other people teaching it, and you can try watching those. Okay, the goal is to understand it as best as possible, and then during tomorrow's period in class, you try it yourself. You do practice questions, and the teacher and educational assistant will be around to help you out with those. That's going to be kind of our new setup for this unit.